Alrighty, we've officially started our fractions unit. This is 2-1, equivalent and simplified fractions. Our essential question, how are equivalent fractions helpful in solving problems? And how do I know if a fraction has been simplified completely? Alright, so moving to our definition section of the notes, we have numerator. A numerator is the top number in a fraction. It tells you how many parts of a whole you have. For example, in the fraction 3/4, the numerator is 3, indicating that you have 3 parts out of 4. The denominator is the bottom number in a fraction. It tells you how many equal parts the whole is being divided into. So for example, in our fraction 3/4, the denominator is 4, and that's indicating that the whole is divided into 4 equal parts. Equivalent means having the same value or amount, even if they look different. So for instance, 1/2 is equivalent to 2/4 because they both represent the same part of a whole. Okay, moving down to improper fraction. An improper fraction is a fraction where the numerator is greater than the denominator. So for example, 7/4 or 9/3 are both examples of improper fractions. If you see or hear the term reduced, it means we're looking for a fraction in the simplest form, meaning the numerator and denominator have no common factors. They've been divided down to the smallest form. For example, 4/8 can be reduced to 1/2 because both 4 and 8 can be divided by 4. A common denominator is a shared multiple of the denominators. For example, if we had a fraction 1/4 and 1/6, we'd use our LCM for 4 and 6 and try to make the denominators the same. All right, let's move over to the notes portion. Equivalent fractions are fractions that appear different but have the same value. So let's take a $50 or 50 cents. You can write that as 50/100, which stands for 50 pennies out of 100, or you could convert it to dimes and do 5 dimes out of the 10 dimes, or a $50, 1/2. Those are all equivalent fractions. I could keep going with this idea and change it to 100/200. I'm going to add on an extra equivalent fraction here, and I'm going to show you a way to test if they're actually equivalent. This will help you with your con later too. So the way we're going to check is we're going to cross multiply. And the saying is cross products have to be equal. So if I multiply 8 times 100, I get 800. And if I multiply 200 times 4, I get 800. So since they are equal, I know that those two fractions are equivalent. So that's a great way for you to check. Okay, moving down to the next problem. It says to make a larger equivalent fraction, you multiply by a fraction equal to 1. Equal to 1 simply means they're the same numbers both top and bottom. So let's say I wanted to create an equivalent fraction for 2/3. You can multiply by any number to create an equivalent fraction. So I'm going to go ahead and choose 4. So notice that's what I mean by a fraction equal to 1. See how this 4/4, what is 4 divided by 4? It is 1. So I know that when I multiply across, my new numbers will be bigger, but it will still be equivalent. So 2 times 4 is 8, and 3 times 4 is 12. So those are two equivalent fractions. Now watch, if I wanted to test equivalent, 2/3 equals 8/12. If I use that cross product rule, 2 times 12 is 24, and 3 times 8 is 24. So I know these are equivalent. Okay, so I'm going to let you guys pause the video, and I am going to have you come up with an equivalent fraction for 7/5, and these answers are going to vary. So any equivalent fraction that is larger than 7/5, go ahead and enter your answer now. Okay, so some potential answers. You could have multiplied by 2 and had 14/10. You could have multiplied by 3 and done 21/15. could have multiplied by 100 and done 700 over 500. So anything where you're multiplying by the same number on top and the same number on bottom will generate a larger equivalent fraction. Okay, and moving down to our last section of notes. Okay, moving to our last section of notes. To make a smaller equivalent fraction, you are going to divide by a fraction equal to 1. So basically, if you're going to simplify a fraction, you are finding the smallest equivalent fraction possible. You're making the fraction smaller. Okay, so our first example, I want to do 10 over 35. Okay, so to simplify this, I want you to ask yourself, what do both 10 and 35 divide into? So you're going to grab your times table chart and you're going to look through the factors and figure out which factor has 10 and 35. In this case, they both have 5. So you would divide both these numbers by 5 over 5. 10 divided by 5 is 2, and 35 divided by 5 is 7. So that's our simplified answer. Okay, for our next problem, I want to do some bigger numbers. Let's try doing 42 over 48. And again, you're asking yourself, you're looking at that times table chart and you're looking through the factors and you're finding what number has 42 and 48 that you can divide both of them by. So as you're moving across that times table chart, you should notice 6 has 42 and 48. So we're going to be dividing both those numbers by 6 over 6. Okay, so 42 goes into 6 7 times, and 48 goes into 6 8 times. So there's our simplified fraction. Okay, and for our last example, I'm going to actually have you guys try this on your own, and I'm going to give you big numbers as well. I want you to do 64 over 80. So go ahead and pause the video and see if you can simplify this fraction correctly. Okay, so there's a couple different ways to simplify this, but I am going to go with reducing this by 8 first, and let's see where that gets me. That'll take me to 8 over 10, and some of you may have thought you were done at that point. You only had to do it once. But if you think about it, 8 and 10 are both still even numbers. So this problem actually kind of is a trick question. You're going to need to simplify it again, and that often happens when we have even numbers. So 8 over 10 is divisible by 2. So this answer is 4 over 5, fully simplified. Alrighty, so that completes our lesson. Go ahead and make sure you do the summary and have a good day. I'll see you guys in class.